Good day everybody, we got a beautiful question. We are expected to integrate integral 0 to 1 ln x over x positive 1 times dx. Now this quantity, or I should say this question, can be easily done using gamma and eta function. You can get the value in one step, but I don't want to use gamma and eta functions because they provide us a simplified form of directly applying the formula. But I want to show you how exactly we can integrate this using, say, integration by parts. Now this can be rewritten as integral 0 to 1. I'm going to write this as ln x times 1 over x positive 1 times dx. Now if you were to take y is equal to ln of x positive 1, then if we were to differentiate this, dy over dx will give us 1 over x positive 1. So what I wish to do is, I would like to rewrite this quantity as integral 0 to 1 ln x times differentiation of ln of x positive 1, because when you differentiate this, you're going to get 1 over x positive 1 into differentiation of x, that's going to be dx, right? So now what I wish to do, I would like to apply the Iliad principle. So I would take u to be as ln x and dv to be as d of ln of x positive 1. Now if you were to differentiate this, I get du is equal to 1 over x times dx. I will integrate this. Now integral of dx will give you what? Integral of dx will give you x, right? Now you have to view it as x, dx. So when you integrate this, this is going to give you this term, ln of x positive 1. Now apply the formula. uv negative integral v du is equal to u dv. So this is equal to u into v. My u is ln x, my v is ln of x positive 1. The limits are 0 to 1, negative integral v is ln of x positive 1. My du is dx over x. Okay, now we need to apply the limits. Now if you were to apply the limits, ln 1 will give you 0, and if you were to apply ln 0, this is going to be ln 1. So this entire term goes off and you are left with negative integral 0 to 1 ln of x positive 1 over x times dx. Now you will have to integrate this. Now the question is, how are you going to integrate this quantity? So let me show you how to integrate this. What I would do is, let me write this down. We now have negative integral ln of x positive 1 divided by x times dx, 0 to 1. We need to integrate this quantity. So what I will do is, I will say consider I to be equal to integral 0 to 1 ln of x positive 1 divided by x times dx. Okay. Now what I wish to do is, I would like to rewrite this as integral 0 to 1 ln of x positive 1 times dx over x. So you have a term like this, one full term is like this. Now if you're not happy that I placed the x down, you can rewrite this as integral 0 to 1 ln of x positive 1 times 1 over x times dx. I think this suits more better. Now what I would do is, I will use the Maclaurin's expansion for ln of x positive 1. Now that is given as sigma n is equal to 1 to infinity negative 1 raised to the power of n negative 1 divided by n times x raised to the power of n. For all values of x lying between the open interval negative 1 comma 1 with a closed interval. So this expansion is valid for all values of x lying with the open interval negative 1 to the closed interval 1. So this is important. Now having given you this, I can apply this expansion here. Now why am I able to apply? Since the limits 0 comma 1 is actually lying between, if I were to take the interval, this is 0, this is 1, this is negative 1, so this is the interval in which this series is defined, this expansion is defined, but we are given a limit from 0 to 1. Right now, since the limit is contained in negative 1 comma 1, we can apply the expansion. Okay, that is the reason. So I would be applying, in place of this I would be utilizing this. So let me go to the next page. So this is equal to integral 0 to 1. Now remember, we have to integrate this quantity, but I am only considering this quantity. Okay, so that would mean I am just showing you how to integrate ln of x positive 1 over x times dx, after which I will complete the final answer. So this is equal to integral 0 to 1 ln of x positive 1 times 1 over x times dx. In place of this, I am going to substitute this value. Okay, sigma n is equal to 1 to infinity negative 1 raised to the power of n negative 1 over n times x power n times 1 over x times dx. Push this x to the numerator. This is equal to integral 0 to 1 sigma negative 1 raised to the power of n negative 1 divided by n times x to the power of n. This is going to be x power minus 1, so I'm going to write it like this, times dx. Okay, fair enough. Now I can replace the sigma in the integral. Why? Because of the fact that this is continuous and bounded. So this is rewritten as, otherwise you cannot change this, rewritten as sigma n is equal to 1 to infinity negative 1 raised to the power of n negative 1 divided by n times integral 0 to 1 x to the power of n negative 1 times dx. Now if you were to, this is straightforward integration, and this is going to give you sigma n is equal to 1 to infinity negative 1 raised to the power of n negative 1 divided by n times, when you integrate this is x raised to the power of n negative 1 positive 1 divided by n negative 1 positive 1, limits are 0 to 1, negative 1 positive 1 negative 1 positive 1 gets cancelled, giving me n is equal to 1 to infinity negative 1 raised to the power of n negative 1 divided by n times x raised to the power of n divided by n. Now the limits are 0 to 1, so this can be rewritten as sigma n is equal to 1 to infinity negative 1 raised to the power of n negative 1, n into n is n squared. This is going to give me n power or 1 power n. Of course the lower limit will vanish. Now this can be further rewritten 1 raised to the power of n, right? That is going to give us 1. So this can be further rewritten as sigma n is equal to 1 to infinity negative 1 raised to the power of n negative 1 divided by n squared. Now the question is, we will have to find the value of this expansion. Now for this we will use the Bessel's result. By Bessel's, it's called as Bessel's problem. We know that sigma n is equal to 1 to infinity. I have proved this result. Please check my channel. This is equal to pi squared over 6. Okay, the complete video is available in my channel. Please watch that. So I'm going to take this result and I'm going to evaluate this. Now before evaluating, if you were to see the terms, if you were to study the terms, n is equal to 1, you get 1 minus 1, that's going to be 0. N is equal to 1, that's going to be 1 squared. N is equal to 2, 2 minus 1, that's going to be a negative 1 divided by 2 squared. And then n is equal to, if I were to place 2 there, I'm getting 2 minus 1. If I were to place 3 there, this is going to give me a positive value. So this is 3 squared, and n is equal to 4. 4 minus 1, that's going to be 3. It's going to give me a negative value. This is 4 squared, positive 1 over 5 squared, negative 1 over 6 squared, plus etc. Now clearly you can see I can actually take the odd values. Odd values are all positive. So let me place the odd values first. Plus 1 over 7 squared, plus etc. These are all odd values. And these are all the even values. All these even values of negative quantities. So 1 over 2 squared plus 1 over 4 squared plus 1 over 6 squared plus etc. So from the odd values I have to take away the even values. Now the question is, what is the odd value amounts to and what is the even value amounts to? So we will come back to this page. I will go to the new page and I will first show you the result of the, I will take the result of the Bessel's function. Now n is equal to 1 to infinity. This is 1 over n squared is equal to pi squared over 6, right? Now even values, let me calculate the even values. Say 1 over 2 squared plus 1 over 4 squared plus 1 over 6 squared plus etc. Now can I write this as 1 over 2n raised to the power of 2, n is equal to 1 to infinity. N is equal to 1, I get 2, n is equal to 2, I get 4, n is equal to 3, I get the third term, and so on and so forth. Now can I rewrite this as 1 over 4n squared 1 to infinity? Can I rewrite this as 1 over 4 sigma 1 to infinity 1 over n squared? Can I rewrite this as 1 over 4? I know this value. This is nothing but pi squared over 6. This is nothing but pi squared over 24, right? These are all the even terms. Now let me go to the odd terms. So odd terms are 1 over 1 squared, 1 over 3 squared, 1 over 5 squared, 1 over 7 squared, plus etc. Now can I write the odd term as 1 over, now to get the odd term we need to be a little bit smarter. So how do I represent the odd term? I'm going to say n is equal to 1 to infinity of 1 over n squared. This will give me all of the terms. From here I will subtract the even terms, right? That's the way we represent. So this is equal to pi squared over 6 negative pi squared over 24. That's nothing but 24. This is 4 pi squared negative pi squared, which is going to give me 6 and 4, and this value will amount to 3 pi squared over 24. 3 divides here 8 times, so pi squared over 8. So therefore 1 over 1 squared plus 1 over 3 squared plus 1 over 5 squared plus etc. has got a value pi squared over 8. Okay, so therefore coming back to the question, so what is this and minus this equal to? Right, we expected to find this minus this, right? So I can evaluate it here. So this is equal to pi squared over 8 negative pi squared over 24, right? So odd terms are giving me pi squared over 8, even terms are giving me pi squared 24. So if I were to take the LCM as 24, this is going to give me 3 pi squared negative pi squared, which is nothing but 2 pi squared over 24, which is pi squared over 12, right? So what have I done? I have calculated 0 to 1 ln of x positive 1 divided by x times dx to be as pi squared over 12. But this is not required. What is exactly required? Let me show you. I need negative, right? Negative. So therefore, let me write that down. Negative 0 to 1 ln of x positive 1 divided by x times dx is equal to negative pi squared over 12 units. So that is the solution for this beautiful question. Thank you everybody. Please like, share and subscribe to our channel. Until we meet again, have a nice day.